let us try an example for the deflection check. This is basically an extension from this previous example, where the beam sections is given here. For more details of the beam, you may refer to the previous example, and you are asked to check for its deflection. You know that the member is simply supported and the span is 12 meters. You may pause the video for a while for you to work out the solution. To solve this question, first you need to know which equations of L per D is being used. You will need to first determine the percentage of reinforcement bar and check against its raw node. FCK is grade 40. Substitute the relevant value, you obtain this. Next, you determine the rho. To do so, you need to determine the provided area of reinforcement as well as the effective depth of the reinforcement bar. Based on the calculated result from the previous example, you know that theoretically you do not require tension reinforcement bar. The prestressing force itself is adequate to resist the ultimate limit state load. You also know that for the serviceability limit state, the member is designed with partial prestressing. Therefore, you should theoretically provide the longitudinal reinforcement bar to control the cracking. Then, during the torsional design, the longitudinal reinforcement bar for the torsional resistance, it will be 12T10. And based on the positions of the neutral axis, there will be 4 reinforcement bar below the neutral axis. That means this 4 reinforcement bar can be considered as the tension reinforcement bar. This reinforcement bar not only provides resistance for the torsional moment, it also helps to control the crack for the partial prestressing, and it also provides resistance to the deflections of the beam. In total, there are 8 units of the longitudinal reinforcement bar undergoing tension. The total area of the reinforcement bar provided will be 628. Next, you need to find the centroid of the area of the reinforcement bar, and you obtain the effective depth of the centroid equals to 540 as calculated in the previous example. Substitute into the equations, you obtain the rho here. It is found that the rho now is less than the rho node. These equations will be used. Substitute the relevant value into the equation. There is a K here, which can be referred from table 7.4 and Eurocode 2. For simply supported beam, the K is equals to 1.0. The calculated L per D now is 36.6. This is the basic limiting factor for the prestressed member. Your next step now is to calculate with the correcting factor. First, you consider the ratio between the width of the flange and the width of the web. The flange width is 2.4 meter and the effective width of the web is 300 in total. It is about 8 times more than the web, which is more than 3 times. The correction factor will be equals to 0.8. The span have a length of 12 meter, which is more than 7 meter. Therefore, the factor will be 7 divided by the effective span of 12 meter. That gives you 0.583. Next, we look into the steel grade provided as the tension reinforcement bar. The steel grade is 460. which is less than 500 Newton per mm square. That means this correction factor is not applicable. We will just use 1.0 for the factor. And then lastly, we look into the AS provided. Based on the calculation, no reinforcement bar is required. However, it is provided with 628 mm square. We simply assume that 1 mm square is required as the AS require in order to make valid of this number. If this one is equal to 0, whichever is divided by 0 will be invalid. And we know that this ratio is going to be extremely large. It is kept maximum at 1.5. Therefore, the factor here will be equals to 1.5. Based on the basic L per D ratio of 36.6, it is then multiplied with the factor of 0.8, 0.583, 1.0 and 1.5. Multiplying all the factors with the L per D limit, you obtain 25.6. Next, we need to determine the actual L per D ratio. The L will be 12 meter. The D is obtained as 540 mm. This will give you the actual L per D ratio of 22.2, which is lesser than the L per D limit. Therefore, we know that the L per D or deflections is acceptable.